Um, yeah, I'm tired actually. I'm going to get some sleep soon. So I designed this in SketchUp, and it's just a test segment that I did, because I can basically pop magnets out and space them out. Because if I take one magnet out, I can leave a gap, and I've been trying out different configurations on it. And to be honest, the old Nikos aren't that important really. If you get the biasing, the negative biasing on the back, that's why I've got the back part there and up there as well, to subtract the field and collapse it on the end before, by the time the rotor assembly gets to that point, it should be pretty dull so it doesn't stick. Anyway, so the old Nikos are useful for fine-tuning things. That's the thing. I have actually got an old Nico in there, and got one in the end there. No, actually those are ferrites. Yeah, I've got an old Nico actually there. Oh, I thought it's a shiny one, and one further back. But the rest of them are just Neos. Most of these are just N42s actually. I wanted to test it on a rotary system. Well, unfortunately, I stuck some magnets in my rotor. I took the magnets out the inside drum, so I drilled some holes and popped the magnets out. And because the 5mm slots in there, I did in this original rotor assembly for the ferrites and the old Nikos. I kind of got stuck with using old Nikos because I can't get anything bigger in there at the moment. So anyway, so I've got some old Nikos in there, but there's not enough drive. There's not enough drive from this to move the rotor at the moment. It does definitely feels like it's turning easier when I when I hold the segment on, but it's not spinning this thing. But so I've got to increase the torque. I really need stronger magnets. I did some tests actually to see what was going on. Now, if I get an old Nico, which is one of these, and I actually stick it on a piece of which is what's inside the rotor actually, if I stick it on this bit of ferrite, right, I'm not sure if I've got this right way around. Yeah, it's very weak, so I'm not surprised it's not turning. I'm not surprised it's not turning my rotor, because the old Nico isn't strong enough. Right, if I've got this right way around. I mean, I'll show you the difference, right? If I stick this on, let's put it on something slippery. Right, stick this hard disk platter on there, it's slippery. Right, I'll show you the difference. This old Nico, using old Nikos in the rotor is not a good idea, because they're just not strong enough. So I can feel a bit of pull there, but yeah, it's weak. So I'm not surprised that my rotor won't turn, but look what happens when I get these big magnets. Right, there's neodymiums with a piece of ferrite on there. Now watch the difference. I mean, it's moving the segment as well. Obviously, it's not, the segment's supposed to be fixed, obviously, but we get a much bigger, stronger pull on here. It's actually, I don't know if you can see that. Oops. Well, I get my there's definitely a bigger gain, so I need to just design another, either put some neodymium. Actually, I wonder if I could get these neodymiums in there. Yeah, I might be able to do it in my rotor. I'll have to do that tomorrow. So I'm shattered. I've been working on SketchUp all day doing these segment things, and I'm kind of knackered. So, but I'll show you the difference. You can see how it's pushing. There's a lot of force there. We do get a little bit of attraction on the very end, but that's because it's ferrite, attracted to ferrite and all that stuff. Come out, you bugger. Right, so because this is dead at the end, you see, there's well, it's pretty dead. There's not much. There is a bit of pull actually. It's actually deflection more than anything. I'll show you what I mean in a sec with a gauge. So now if I get the take this slippery thing out of the way because I want to show you with my gauge like I was doing before, because it's a lot easier to see what's going on. So if I get my magnetic gauge thingy and I approach it from the bottom end, you'll see it's not pushing anything, and we get to about here and it kicks it out. So, but I'm fine tuning the end at the moment, this end. So I'm actually 3D printing another segment right now, which has got some little tweaks on the end exit part there, because I want to tweak that up a bit so it's got more push on the exit side. I did have a dead end on, I did have it dead on this end where it was no magnetism at all. I've got a bit of shielding there, I don't know if you can see that. Got a little bit of nanocrystalline shielding on the end there, on the exit point, and a bit on the entry point. So I was playing around with that and it just seemed to help. So yeah, look at the pull on that. I mean, there's quite a bit of push on there. So yeah, just get this on. I'm trying to set it up so that I can do another test and it keeps running away. Right, so as I'm approaching, the important thing is as it's approaching, it's not pushing this away, which is what we want. We don't want it pushing it away. As obviously the other thing to think about, I'll explain that in a second. Well, we'll go to that and it kicks it out, so that's good. The other thing as well with the rotary system, the magnets are not actually in a straight line because it's on a rotor. It's actually in an arc like this. Now if I do an arc on here, if I simulate an arc, I can't really. Well, I think the way to simulate the arc really is to, right, you know this turns like this, as in an arc, right? So the way to simulate that would be, would be for me to actually, as this is moving, I'd have to quickly rotate this, like that. But trouble is, it's very hard to do. But you get what I'm saying. In order to simulate this being on an arc, I need to do that. You see, it works. It does kick it out. Right. So this would be. Oops. Except I went too far. There's magnets at the back. You see, on the back of here, on the ball bearing at the back is the other pole, so it's going to stick to that. So I've got to be careful I don't get that in the jaws sort of thing. So this is simulating a rotor. I'm going to do that. Now that this is in a piece of plastic, it's kind of easy to do. So that's basically simulating the rotor. So instead of the rotor doing that, I am trying to do it with that, you see. So we can see it does actually work. Oops, it fell off the table. Right, it does that sometimes if I get it in the wrong position. It's got to be lined up right, but it's not, generally speaking, it's not pushing it, except when it goes in there, in the jaws. Right, let's try, I'm just drooping again, droopy cam. There we go. So anyway, it does have quite a bit of kick on it. I just need to get some decent magnets in my rotor now to actually see if it turns the damn thing, and I'm thinking it will. Why won't it? I mean, it's moving this thing along, so it should do. So what I'm trying to do is simulate the arc, you see. So you get the idea. Oops, knocked it on the floor again. Right. Okay. I'm not sure why it does that. It might be because I'm pushing this end. Oh yeah, I don't know. Not sure why it does that. This table's not level anyway. Right. So yeah, that definitely kicks it out. I have to keep doing this over and over again to convince myself. Because it's one of them things where you think, is it working, is it working, or is it not working? You know, well, I've got to sort that rotor out some more, hopefully, over the weekend. I'll get some stronger magnets in the rotor and then we should be able to see the difference. But at the moment it doesn't do a damn thing because, well, it feels weaker. I mean, when I'm turning it, it feels like it's doing something. I just really, so all I've been doing is holding it in there, but I can't really do this when I'm holding the phone. That's the trouble. I can't do it when I'm holding the phone. Anyway, it doesn't turn on its own. That's all there is to it, and there's not much point in showing you because those Alnicos are in there and they're just too weak. I'll show you how weak they are. I mean, look, get my gauge. Oops. Right, get my magnetic gauge, right. Let's find, there's two Alnicos in there, right. It's not even moving my gauge, look, so that's why it's not turning. Yeah, it's not even moving that. If I turn it on its side, like this, like that. Oops, gravity got it then. Turn on its side, you can barely see it move. Actually, come on. You see, I have to tilt it back a bit. It's too weak. So it won't turn the rotor yet, but I'm going to start that. I'm going to start that out over the weekend, see if we can get some stronger magnets in there. Because as I said, the Alnicos on the rotor are just a bad idea. Just no good. I think another way to show you that is to put the Alnico, the little trough thingy, and let's try to, I don't need to fly off. You can see how far it deflects that, right? Not very much, right? You can see how far it pushes that. Let's get some neodymium magnets. I've got some small neodymiums here. Let's put some of these in there. I'll have to get it right way around, which is that's the way around. Now watch the difference with these neodymiums. You see that they're a lot stronger. It pushed them a long way there. Oops! They even flew across the room then. Right, so come on! Get off! Stupid thing. I'll stick it on there a minute. Which is the right way? That's the right way. Right, we'll compare. It's probably going to jump out now. Halfway up, and that's as far as it went. Right, let's try the other ones. I think I've got these right around, yeah. We'll do the same thing with these. Oops. You see it's already moving, look at that. Look how much stronger these are. So if I put some of these neodymiums in my rotor, we should see it move. Well, we'll have to find that out tomorrow. I'm so tired. I've been working on this thing. Oh, I've done 3 versions of this. I also did a mock-up because I didn't want to waste too much plastic, so I printed 2 layers of this, which is very thin, and I could stack the magnets in the bottom row and then stack the magnets in the top row and having this magnet sandwich. I tried this one out, useless. I thought it would be. That's why I only printed it that thick, so I wouldn't use a lot of plastic. But the best one so far is this one. I'm hoping the modification I made to the other one, when that's printed, that's going to take 2.5 hours to print that thing. I'm hoping that when that's printed it should be a bit better, because I tweaked the ends a bit on these magnets. I put a rotation in the magnet on the very end there. I've also made it possible to put this magnet in the end one in 2 different orientations. One is with these 2 basically facing outward slightly, and the other orientation is with one facing out slightly and the other one facing inward slightly. So, well, it's a different plane, you know. So one's lined up in this pole and the other's in this pole, so it's sort of a cross, yeah. Anyway, so I'm waiting for that to print, and I can't really do much because you can't stick these magnets in putty or anything like that, because they're so strong. They just, everything just gets squished. I know some people use glue guns and all sorts of things, but yeah, it's a messy way to do it, and it's not precise as well. You can't repeat it. If you get it and it works, and you can't repeat it exactly, can you? So it's better to 3D print something, and then you know if it works, it works. If it doesn't, it doesn't. So as I say, I can just, oops, everything's sticking to this thing now. I just drop this on there and it goes. Oh yeah, there's something else I made. I got one of my old plastic runner things, which which I made for this thing actually. These are the shells, and I stuck some rubber, amalgamated rubber to elevate this so it would be in the middle, and so it wouldn't twist. Because if I put this on here, the whole thing goes around because it grips really well. Trouble is, it's a bit sticky, right? Because it's sticky, and this thing's not exactly flat anyway. Because it's sticky, this thing stays on the runners, which is really cool. So now I can do things. Oh, I've got it lined up wrong. Yeah, there is a bit of push on the beginning. I'm sorting these things out at the moment. I need to move this back a bit. It's too close. Right, stick this on here. Right. So what I can do now is move this. You can see how much kick that's got. This runner is really good because it's nice and straight. It's a bit warped. It's not perfect. Hang on, let's have a look at the angle. It's actually pretty straight now. I've been straightening it out with acetone in my acetone bath. It's not bad. It's got a little bit of a wobble in it. It's not perfect, but it's good enough. Let's just try this again. Right, so if I bring this creepy, see, we'll push it off because there's a bit of push on this end, which I'm trying to sort that out as well. I have to rebias my Alnico, I think. It's only when it's at this elevation. Doesn't do it when it's low down for some reason. When it's low down, it doesn't do it. So I'm still working that out because the Alnicos behave weird at different pitches. So let me see. I'll put this that way around. Stay. Right. So let's just bring this in. Go right up to the end and bounce back. Well, it bounced off that thing, it hit that stopper and came back. So let's see if we can push it along. Yeah. Gravity seems to be bringing it back. Let's test that. Ah, it is pulling back a bit. So yeah, this is what I need to sort out. There's still a little bit of attraction on the end there. And so I'm balancing this out at the moment. This is what the new print is going to hopefully sort out, because I tried the magnets in different orientation. I swapped some of the magnets around, reversed them, tried that. I couldn't quite get it right, but because I'm working with a 3D printed thing now instead of a load of stuff hacked together with bits of little magnets sticking out and everything. I haven't tried that actually. Let's try sticking a couple of little magnets on the ends of this thing, like that. Let's try. I haven't tried that bit yet. See if that will do anything to reduce that thingamajig problem. Right, let's try this. I've got to be careful not to rub my magnet off because it's on rubber. Oh my god, that was good. Hey, that worked better. It went right off the edge. It went right up that step as well. Bloody hell. Oh, that did. So look at that. Just putting them little magnets on there made all the difference. This is what I'm saying. I've been experimenting all bloody day with this thing. So that was really good. Let's try that again. Oops. I need to negative this end. Let's try that with the little magnets. Let's get two more of these. Hang on. Oops. Right, let's get two little magnets on the end of this ferrite. See if I can get rid of that problem there. Right, let's try that now. Oh, my thing's not flat now because it's resting on magnets. That's a problem. Let me just try. I'll rest it on this bit of ferrite at the back. Right, that should maybe help me slide it around a bit. Ooh, I wasn't ready then. It went. I wasn't ready. Right, let's try that. Oh, it still rolls backwards, so let me just try flipping the magnets over. Oops, I don't think you want to go. I think there's too much flux on there. Oh, yes, it will go. I managed to flip that one over. Let's try the other one. Come on, you little bugger. Where are you gone? Oh, it's pulled out that other magnet. Oh, I've lost it in the hole. It's going in the hole. Shit. Hang on. It's just going in that hole. Yeah, how do I get that out there now? I'll just get another one. Hang on. Let's try putting another magnet on there like that. So I'm doing this holding mag thingy, and I've lost my ferrite. Hang on. Right. I'm too close, it wants to roll straight away. Right, let's try this. Yeah, it's still pushing back a bit there. But it's not bad, it's only a little bit. I mean, this is really slippery. This runner is very smooth. It runs really easy on here. I'll show you what I mean if I blow on it. See, I just blew on it. That's how easy it moves. Yeah. Yeah, that's definitely got more kick in it than it had before. So it's just that very beginning at this point. I did print that other thing where I tried putting some magnets in the very end to subtract, and it just messed everything up. So you've got to fold the fruit. You got to beginning, and then these where I had the ferrite in before, I've stuck 3 magnets close together, and then I've got the magnets further up here, and they're kind of spaced out a bit more than they were when I had them in the stuck on that piece of blue tack and stuff where it was all held together. So having some gaps does make a big difference, but the main thing is this thing really does just pretty good, really. Let's try. See, it rolls so easy there. I mean, there's not much force on there, you know. There's really not. It's just it rolls easy. I mean, I don't have to show you. I mean, when I blew on it, it moves. So I mean, you can see what I mean. There's not much force, but there's a lot of kick there. See, when I do that, you see how much kick it's got there. So when I bring it in there, it moves really fast. But here it's barely moving. Right. So, oh hell! I picked a load of junk up, look, with my magnets. Oh, this is, flipping it. Oh. Oh dear me, everything's falling off the table now. Right. wasn't ready and it went. I didn't blow on it, honest. It just, yeah. Right, I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8. You see, I'm not blowing, I'm talking. Right. Oh, it went right on the head, man. It's kind of fun, this, you know. I can't wait to test it in the motor on the bearings and that, see if it actually turns. This one took 2.5 hours to print. For some reason, that one I'm printing now is 2 hours and 40 some minutes. I don't know why. I think it's because there's more holes. It has to make more travel moves or something. But yeah. So let's try this from above. Oh, I wasn't ready. Flipping things stay. Right, I was going to say let's try this from. It's so sensitive. I'm right over already. It's moving. Right, let's try this from above. Right, from the side. Right. Let's try it under the table. Oh yeah, everybody likes to say, oh, you've got something under the table. Well, look, there's nothing under the table. But there will be, because I'm going to put this under the table now. Let's try it. Let's try it under the table. Nada. Nothing. Too far away. I don't know. Well, I'm under the table, look. It's not doing anything. Right. Okay. And I know you wanted me to try that because a lot of people say, oh, you're doing something under the table. No, this wood's too thick. It's about 1 inch thick, anyway. I don't know why it won't work under the table, actually. In theory, it should do. It should work under the table because it's... Unless it's stuck. I don't know. It's weird. Will it work from above? Oh, it won't work from above either. Oh, well, that explains why it won't work under... Oh, it did then. Well, that explains why it doesn't work under the table. It's not getting the field in the right direction. It works from the side. It has to work from the side. Oh, I know why. Because the polarity, we've got south on this side, north on that side. So if I'm doing it from above, it's cancelling itself out. That's why it won't work from under the table. It has to be from the side. That makes sense. Yeah. I was a bit disappointed when it wouldn't turn the rotor, but them Alnicos, they are pretty weak. They're not as strong as Neos. So, yeah. It's funny when it rolls off the table, actually. So, yeah, a little update. I've been waffling for nearly half an hour. So, yeah, I think I'd better go before I just bore you all to death. I'm going to watch a bit of Kojak. Actually, I paused it. Oh, the audio's going. So yeah, I'm going to watch some more Kojak for a bit, and then I'm going to get some sleep, and tomorrow I'll sort something out in them rotors. Maybe I can get them these little magnets. I think they might fit in the rotor. I think I can get them in. That should make a big difference. Yeah, can't wait. Alright, see you later.